Hey guys, welcome to Teach Me Math. Today we're going to be looking at special quadratics. Sounds very special, but there's really nothing to it. There's only a couple of scenarios we've got. We have the perfect square trinomial and we've got the difference of squares. Before we start talking about the perfect square trinomials, you should be looking at these numbers. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and 169. It could be more, but I really don't know anything past that off by heart. Right? What are these numbers? These are perfect squares of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 11, 13, right? If you didn't know that immediately just by looking at it, then I suggest you take some time and try to memorize just these numbers, and it will really help you out a lot in terms of identifying perfect square trinomials very quickly. Alright, and I'll talk about the difference of squares in a little bit. But first, let's start off with perfect square trinomials. So those were perfect squares that you saw before. These are perfect square numbers because they're 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, blah, blah, blah. Trinomials is when we're talking about the quadratics. So let's take, for example, x squared plus 4x plus 4. Now, we know from our method of factoring that the factors of 4 are 1 and 4 and 2 and 2. And in this case, we can see that 2 multiplied by 2 is 4, and 2 plus 2 is going to be a 4. So these are going to be my two factors, and they're going to be added together, right? So it's going to be an x plus 2 and an x plus 2. Now, if you think about just numbers, if you see a 2 multiplied by a 2, you know that's the exact same thing as saying 2 squared. And it's the exact same situation with quadratics, right? If you see two factors and they're exactly the same, you can also rewrite this as an x plus 2 all squared. That looks like a weird 2, that's a 2 squared. This is called a perfect square trinomial, okay? Well, this is called a perfect square trinomial, right? And its factor is a perfect square. Now, instead of every single time you see one of these trying to figure out what finding the roots manually, right, or taking the long route, you can learn to figure out how to spot a perfect square trinomial without having to do all of that. So when you get, for example, an x squared minus 10x plus 25, you see that 25, you're thinking 5 squared. Oh, well, if this is a 5 squared, if I multiply this 5 by 2, am I getting a 10? You're right. You do, so this should be very odd. It's a negative 10, so it's 2 negative 5s. You should be automatically seeing an x minus 5 all squared in your head. Alright? Now, this follows the formula of a plus b all squared is equal to a squared minus plus 2ab plus b squared, and a related one would be a minus b all squared is equal to a squared minus 2ab plus b squared. In our case, or in the majority of cases, our a is an x, right? So if you think about x minus b all squared, you're thinking x squared, which you get a lot, minus 2bx plus b squared, which is why I'm saying if you see this 25, you're thinking b squared, this is 5 squared. Oh, well, if I multiply my b by 2, am I getting a number here? If I multiply 5 by 2, I'm getting a negative 10. So I know automatically that I'm looking at an x minus b all squared type situation. Alright? Straightforward. I suggest you memorize these, these two. It'll really help you out when you're looking at perfect squares. If they're trying to get you to simplify an x minus 6 all squared, well, instead of trying to multiply it in, right, I've had students, they'll open it up first, x minus 6, and then do an x squared minus 6x minus 6x plus 36, which is correct. It's absolutely not wrong, but it's unnecessary, because as soon as you memorize this, you're going to know that your x minus 6 all squared is equal to x squared minus 2 times 6 times x plus 36, right? Plus 6 squared. And then you can start to do this in your head, and you'll just end up being able to do this entire thing in your head, which is x squared minus 12x plus 36. And you've saved yourself a good 30 seconds. Alright, our next thing we're going to talk about is the difference of squares. It's pretty straightforward, just based on the name, is a difference of squares, right? The formula is a squared minus b squared is equal to a minus b multiplied by a plus b. So an example of this would be x squared minus 4, let's say. Our 4, you should automatically see that this 4 is the same thing as saying 2 squared. So x squared minus 2 squared, and then just following the formula blindly, we'll get an x minus 2 and an x plus 2, and we're good. So these are the two factors of your difference of squares. You can do this with an x squared minus 9, which is a 3 squared, this is 25, blah, 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 anything you want. Now, they do like to trick people with the difference of squares. They might put something that's not a perfect square, and that's also okay, because let's say you take an x squared minus 5. Are there two things multiplied by each other, or like something multiplied by itself, that will give you a 5? And the answer is yes. You will get an x minus the square root of 5 times the x plus the square root of 5, right? Because a square root of 5 all squared, right, is equal to a 5. So this is a square of the square root of 5. I know I'm saying square a lot, but you should see that this is correct, right? And then, so if you think about it like that, right, so if you write this out as an x squared minus the square root of 5 squared, you can see how this will be the correct answer, right? You can also, sometimes they'll like to do this one a lot, which is x squared minus 1 is equal to blah, blah, blah. And then you're thinking, oh, well, 1 isn't a square. There's no square here, so I can't really do anything. It's not a difference of squares. But if you just take 1 extra second to think about it, you'll see that a 1 squared is equal to a 1. So this is exactly like saying a 1 squared. And then this would be just an x minus 1 and an x plus 1, right? If you have any questions, please feel free to message me, and I'll try to get back to you as soon as I can. Thank you.